And it also does feel a little bit magic. And one of the things, particularly for me, and I hear this a lot, one of the things that attracted me to Go was that it didn't have much magic in it. It was a very clear and simple language. So I now might even be too far the other way of allergic to magic, despite having the appearance, some have told me, of a magician.
Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode cloud servers. Head to linode.com/changelog. This episode is brought to you by DigitalOcean. DigitalOcean's developer cloud makes it simple to launch in the cloud and scale up as you grow. They have an intuitive control panel, predictable pricing, team accounts, worldwide availability with a 99.99 uptime SLA, and 24/7, 365 world-class support to back that up. DigitalOcean makes it easy to deploy, scale, store, secure, and monitor your cloud environments. Head to do.co/changelog to get started with a $100 credit. Again, do.co/changelog.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from around the Go community. Next week on Go Time, find out what happens when a new hire, an intern, and a high school programmer walk into a podcast. Right now, it's a listener-requested episode on reflection and metaprogramming. Here we go.
Hello and welcome to Go Time. Today we're talking about reflection and what that means in Go. We'll talk about the Reflect package, what you can do with it, and some really interesting use cases for it, some examples around the standard library even. And then we'll get opinionated about it, no doubt. So, joining me today is Jaana B. Dogan. Hello, Jaana.
Hello.
Welcome back. How are you doing?
Good. How are you?
Yeah, not bad, thanks. And we're also joined by, because you, Jaana, if you don't mind me saying, you don't sound that happy to be here. But don't worry, this will cheer you up. John Calhoun's also here. Hello, John.
Hey, Matt. No, she looks like she's deep in thought about something. Nobody else can see the video that we can, but she looks like she's deep in thought about something.
Yes. Well, it's probably, she's reflecting.
She's reflecting.
I'll reveal what I'm doing. Exactly.
Okay, yeah. Okay, so maybe we should just start at the beginning at high level. For anybody not familiar, what is reflection and what does the Reflect package give us?
At a high level, it's kind of just a way of almost metaprogramming or like interacting with code at runtime is a way I'd view it. I don't know what the official definition is, but everything I've ever seen that's using it is while your code is running, you want to examine other pieces of code or look at other things and see, find some information about them or maybe try to modify different aspects of them. So it's these things where rather than doing it as a developer at coding time, you're doing it later when the program's running.
Yeah, so dynamic languages do that all the time, don't they? Like Ruby and I think even JavaScript, because in JavaScript you can take a string and add methods to it at runtime, and you can kind of do anything you want. It's a really flexible language. And one of the things about Go is it is a strongly typed language, and so sort of deliberately doesn't do that. But of course, the Reflect package is an exception to that rule.
I'd say that, like like you said, the dynamic languages, it's almost like it's not even thought of as something separate. Like it's just part of the language. It's just something people naturally do. And if you've ever coded in like Ruby or one of those languages, it seems so natural because you see everybody doing it. It's not, it's not something that would stick out in any code base. But when you get into Go, it's not only is it specific, like you have to import this Reflect package, but it's also very, very limited in what it can do. And I think that's intentional, and it doesn't sort of go with the story of what Go is trying to achieve.
coming from a strongly typed background, I was about to say that like reflection is everything that your type system cannot provide as a first class, capability. But then I was looking at the Wikipedia page, and that's why I was so confused about the definition. And like I was like, in the thoughts, and Matt was thinking that I was being said. It says reflection is the ability of a process to examine, introspect, and modify its own structure and behavior. So it just like basically is everything. And then, that kind of actually makes sense if you think about the meaning of what reflection means in, daily language. So I think it's not even bounded to that like little, I try to, I think, overspecify in my mental model. It's just more of like everything about introspecting and modifying the structure and behavior.
Yeah, when you do type assertions in Go, in a way, that's a kind of version of this, isn't it? You're saying at runtime, you're saying, here's a type, and we don't know what this is, but I'm going to assert it to a particular type. And if that's successful, I can then kind of branch off and do something. So in a way, that's kind of reflecting, isn't it, a little bit? But that's still happening at compile time, isn't it?
Yeah, you can definitely put more checks there from compile time. But like the actual checking, I'd assume some of that has to happen at runtime because you don't actually know.
No, the check-in assertion is happening in the runtime, so you can say that like, it's an introspection piece and it's actual reflection, but the type system is providing a very nice like feature for us to do it in a nice way rather than like depending on a reflection package or something. So you can say that like, that's a reflection behavior, that's a reflection feature, but represented in the language with more synthetic sugar.
Right, yeah. Yeah, and it does help as well. It does some checks. You can't do invalid kind of type assertions and things. The compiler will help you at some point. But you're right, of course, it has to be at runtime. That's kind of the point of it.
Yeah.
Yeah, it's definitely interesting in that sense. So I guess like the type assertion one is one of the ones that I think everybody's probably seen. I'd say that the second most common one people have probably seen is struct tags. And while they might not be using them like directly themselves to read them, I'd say that most people who write Go have at least seen struct tags and wondered like, what is this thing? So I think that might be another one to jump into with Go, because I definitely think that's the second most popular use case.
Yeah, so anybody that's not familiar, and you see this particularly if you're working with JSON data, you can actually put a string after a field name in a struct, and that string can be parsed at runtime. And then, of course, it can take metadata out of it. And the JSON example it allows you to specify the field name, so you can have a different field name to the one that you're using in the struct. And you can also optionally choose for it to not include that field at all. And you can also, there's like a syntax with a string and then a comma, which is, quite a strange part of Go, actually. It's quite unusual, isn't it? There's not much else like it. And you can also tell it to omit the field if it's empty. So if it's its default value, then it won't be included in the JSON object. And that is kind of, I remember when I first saw that, it really felt like almost a temporary thing, but it has proven to be very useful and pretty effective for that, in particular, that use case. But John, you wrote something that used struct tags as well, right? That form project. What was that?
So I've done a couple different things. Like historically, I've used reflection in a lot of different projects. So I come from a Rails background, and like Rails is essentially a large exercise in using reflection. Like that's kind of how I view that whole framework. So it was nothing as crazy as that, because in Go, I just don't think that makes as much sense. But I wanted to write some code that essentially I wanted to take a struct and I wanted to generate an HTML form out of that. And then I wanted to later be able to parse that form whenever a user submitted it, and to, basically take all the values they submitted and put it back into that struct, just to make my life a little bit easier so I could reshare that across a couple different handlers and just make that sort of thing simpler. So I created this form package that used struct tags, and there's other ways to approach this, which I think we should talk about. But it was kind of me just looking at the problem and being like, is there a way to handle this? And the struct tags were used for things like if you needed to change the name, like if the name in your field had, say you had a name or you had a struct and one of the fields was named email, but you wanted it to display e_male in the actual form, like as the name in the HTML, you could use struct tags to kind of change things like that. And that's where I was using it. But it also was like an interesting exercise in the sense that it showed how confusing reflect can be in Go to write, like to use. So I think that's something that a lot of people struggle with when they get there. And part of me feels like that's intentional, like something that they did, not like they wanted it to be worse, but they didn't like want it to be so easy that people just jumped in there and used it for everything and when they shouldn't be.
Yeah. Yeah, because there's so much benefit to the type safety. It makes sense, doesn't it?
Yeah, and I also even found like when I was doing this, I probably used struct tags more than I should have in that. Some examples of that were like if you had helper text or default values or anything like that for input fields, I actually had so you could just put struct tags in there that provided those values. And as a result, you could have a pretty crazy long struct tag that was thrown on something, and it looked kind of wonky because you're like, this isn't really code, it's like this metadata, but it's providing a lot more than what it seemed like at first glance.
Matt, you said something very interesting that like when you first saw it, it looked almost temporary. That was like exactly how I felt because, I have this like concerns as well. Like, hey, this is sort of like, Go is a very strongly typed, simple language, but, sometimes I feel like I'm over abusing struct tags. And I was expecting something like an annotation, right? Like in other languages, we have annotations and you can have like typed annotations and, annotations can handle more complex situations without sacrificing too much from the type safety. And I was expecting something like that. And this was like, one of the earlier, like a very long time ago in the early beginnings of the language. But they wanted to keep everything small. The language didn't really grow to have annotations. And one thing that I realized that I don't see a lot of big mess when it comes to struct tags. Like I think people, use one struct tag at a time for very like specific things like, JSON, for example, keys and that sort of things. Well, what's your opinion on, do you think that like, it's at a level that we don't actually need anything like an annotation, or do you think that like it's a missed opportunity just because struct tags are hard to maintain and so on, like we are not like doing a good work, or like we're missing some opportunity to annotate fields in a more richer way?
Yeah, it's a really interesting one because there's definitely value in being able to add a bit of extra metadata for a particular use case to structs. The alternative has to just be you would describe the same thing just using strong types. So, John, in your case, instead of having like an address struct with different fields and then use the struct tags to add labels and placeholders and help text and things, you'd have a form type and then a field type probably. And it's quite verbose, but it's very clear. So I guess that's the benefit. But I always was told, and I don't know about this, but I was always told that it's slow, that like struct tags are slow to parse. And is that the case still? Has there been any work optimizing that, or is it actually pretty quick?
I don't know, but I've never worked on a project where that type of speed has mattered. Like if I'm rendering HTML and sending it back to the user, chances are sending that HTML back to the user is going to take significantly more time than whatever the reflect struct tag parsing is going to take. So it just wasn't a major concern. And I will say, when you talked about the form, like having a form type, I need to get this into GIS and share it with the episode. Like maybe I'll put it in the show notes. But I actually have two versions where one I actually did with a form package that takes something like that and takes a struct and just generates some HTML if you provide like an HTML template. And then the other one is more of a, like you describe, a form type. I'd have another struct that would be like, this is my sign up form struct. But I would write a method on that used my generic form type and basically spit out like what that should look like. And I knew how to render that in HTML with my templates. So I didn't use reflect at all in that version. And you're right, it is a lot more verbose. But I think that in some ways it's definitely better because it's much clearer what's happening. And then in other ways, it's kind of just depends on the type of project, I think, is what it comes down to. Because for some quick project where you want to throw a form up, it's nice to have that, this package just does it. In other cases where you're going for like, this is going to be a much larger or much longer lived project, we might need way more customization of stuff. Like sometimes it makes sense to go with something a little bit easier to change and a little bit more verbose, but as a result, it still gets you the same results.
Yeah, I know that the old data store in App Engine used to use them. Usually it was around field names, but you could also specify like that you didn't want an index to be built on a particular field that you were then going to put in the data store. So, I mean, it's extremely powerful to just be able to annotate your structs in that way. And it makes sense because you really are talking about properties of that field in a very real way. So, yeah. And, typed annotations, which is, I remember that from C#. I think Java has it too. And so the idea there is that you have actual types in your code and you can use those to annotate fields. And then I suppose you can check to see for the existence of those, and you can probably interrogate them and programmatically process them. That's a kind of cool meta programming approach, and you still probably get a lot of type safety with that too.
Yeah, also maintainability is higher. You can also easily run queries you can ask your editor to hey, show me all the uses of this annotation. Or you want to, let's assume that you want to modify a value in an annotation. You can easily, search for that and just kind of go and refactor everything all around. So having some type safetyness kind of allows you to do that. But again, as I said, I don't think that we're over abusing struct tags in Go. Maybe it's because they're not typed or whatever, so everybody's kind of cautious about not over using them. So I think we still kind of have a nice balance. They're very small, but I think the biggest problem is people are afraid of, since they're unstructured and you need to parse them. People are thinking kind of scared of the maintainability as well as some of the performance implications if there's any.
I agree entirely with what Jaana said, with the sense that it might be because that they're a little bit harder to maintain, that people don't use them as much. Whereas if you put those annotated tags in there, I almost wonder if people would use them more than they do now and use them in cases where they don't make a lot of sense. Because I've even seen that with struct tags where I think there's a class of problems that make sense for struct tags, like encoding with JSON, or really encoding with almost anything that's similar to that. Encoding is a great example where your struct might not match exactly how it needs to encode, so you need to have some way of defining how it should encode and decode. And ORMs are kind of the same. They kind of fall into that same class, where if you're building an ORM where you just want to quickly say, put this into the SQL database and here's what the names of the fields are in the SQL database, that makes sense. But then there's other libraries out there like validation libraries where you throw things like this field is required. And I'm not trying to say people should never use those, but I do see those as potentially being problematic long term. They could lead to code that has a bunch of different struct tags all littered in this type, and it's really hard to understand what each struct tag is actually doing, how they all interact together, and there's no compiler safety. And if we put annotated tags in there, I wonder if people would just be more willing to do that rather than look at other approaches.
Yeah, I've seen linters that check the JSON tags. So if you miss a quote or if it's malformed in some way, then I had it once, some linter will say, oh, this is malformed. It's not done by the compiler, so it's not quite the same safety. But I wonder if there is a sort of benefit of it not being a very attractive API, that people tend to avoid it for that reason. And it also does feel a little bit magic. And one of the things, particularly for me, and I hear this a lot, one of the things that attracted me to Go was that it didn't have much magic in it. It was a very kind of clear and simple language. So I now might even be too far the other way, of kind of allergic to magic, despite having the appearance, some have told me, of a magician.
Yeah, the magic part is, it's hard because I remember the first time I used struct tags when I was first learning Go. I think I was doing something with MongoDB, and you use, I think it's BSON to define sort of the struct tags. And I remember when I was doing that, I'm setting up these struct tags, and in my head, I'm sitting there thinking, do I need to import something for this to work? Why is my code okay with this being here without me importing that? And it really confused me for a while because I'm just I don't understand how this is compiling. And it wasn't until later when I dove into stuff and sort of understood it, but at the time it really did feel like magic. And that was slightly frustrating when I was first, learning about it, because I'm I don't know what's going on.
I mean, it's literally a string, isn't it?
Yeah, but you still, you're surely the compiler's doing something with this, it leads to things being written somewhere, so you're how does that work? And it was just confusing for a while. And then later when you realize, oh, they're just parsing this string and, the bsom package later when it's being used is doing it, then yeah, that makes more sense. But at the time, I was just very confused as to what was going on.
Yeah, the Reflect API to interrogate those struct tags actually is quite good. It's quite a simple API because some of the Reflect package it's so meta, isn't it? And some of it makes sense. Like you can get the value of something, and the value is a struct, it's a strong type in the Reflect package, and that describes the value. And then, but values, of course, because they can be lots of different types of things, you end up with loads of methods that most of the time are illegal to call. Like if you try and get the length of an integer, of course, the methods are there in the Reflect package to do that. So at compile time, you could do it. And it's only then at runtime you're going to find out you can't get the length of an integer. There's lots of examples of that. So you do end up checking everything. You'd be very verbose when it comes to kind of writing defensive code to make sure that you're not going to have any of these runtime weird things. And obviously testing and things helps. But
yeah, you mentioned testing, but it's hard to test as well. There's no a canonical set of tests that you want to run. I worked on some of the database packages, and there was all this since Go doesn't have generics, which is something that maybe we can discuss in the context of this talk. We rely a lot on interfaces and type inversion. And, if you have a slice of interfaces, it could be either a value or a pointer of pointer. Then you have to do all that magic by using the Reflect package. And Reflect package is already a very verbose thing. So wrapping and unwrapping all of those types is very hard. And I couldn't figure out an easy way to test because there was no set of canonical things hey, if the standard library was providing maybe some sort of hey, please consider testing these, or providing a list of things to test, that would be so much easier.
Yeah, because you have to probably test for all the different possible types and things like that. And then, of course, arrays and slices.
Exactly.
Yeah.
So it's interesting that, Matt, your example of one of the easier use cases was the value of, getting the value of something. And the funny part was that was one of the first ones I had issues with when I first used the Reflect library, because when somebody passes something in, they pass in a string, you're like, okay, I'm going to get the value of this. And that makes sense. Your code works and everything seems great. And yeah, there are things like length and stuff like that might not work, but that isn't always going to work. But then somebody passes in a nil pointer that has a type, but it's a nil pointer. And all of a sudden your code breaks and you're like, what just happened? And you end up with these weird cases where if the type kind is a pointer, and if it's nil, then you need to use reflect.new to instantiate a new element. And then if it's an interface, you need to get the underlying element type that it's pointing to, because the interface doesn't really help you much. There's all these weird cases that you get to where it seems really simple. I just want the value of this, but that's really not what's happening. So you end up with all of these edge cases. And even once you get it working and you have some tests where okay, we pass in an empty pointer that has a type, we pass in an empty interface, we pass in an actual value set to that interface. You have tests for all these. At the very end of it, you're still thinking, I don't know what edge cases I'm missing, because there's gonna be one. There's almost no way that there's not.
Yeah, I mean, in a way, it's leaking the internals of how Go actually works. You do tend to learn quite a lot about the type system if you do have to use it. But frankly, I often end up in a kind of trial and error situation, relying on a TDD process to tell me if I got it right or not. I've often written, if I've used the Reflect package, I often will have code where I call the LM to get the element, and then for some reason, I'm not sure why, I have to call it again. And it's there will be a great reason for that, but I don't know what it is, and I don't really have time. And I know that if I just call lm.lm, then I get the thing I need in this case because the test passes. So I end up being very sort of brute force when it comes to reflection coding,
yeah,
which doesn't feel great,
I don't use TDD that often, but using Reflect is one of the cases where I most definitely use it, because I'm here are all the different things I know I'm going to put into this, and they all need to work. And it's just so much easier to start with that, because otherwise, you're just yeah, this works, and then you go to run it and nothing works, and you're I don't know what's going on. And I'm looking at some code that I've written with Reflect, and I'm seeing the same thing where it's .type, .lm, and then once you create that reflect.new using that, you're .lm for that, and you're I don't looking at this code, I'm like, I have no idea why I did these things. I just know they work, which is really weird.
One thing that I realized that also, I think the current type system of Go is like contributing to some of these problems because, we kind of like fall back to this like interface as an argument or like slice of interfaces as an argument. And then, like all that like type inversion, just because you can't limit what the user want to do or what the user want to pass, like you have to handle all of those cases, for your library to work. One typical example from the Spanner Go packages we have is it has to do type inversion from the argument that the user is passing, which is like some interface, and it could be anything. It could be a struct, or it could be like a pointer to a struct or an array or whatever. But it has to know about the type by doing type inversion. So you shouldn't be passing a regular nil, and you should be passing a typed nil. So Go has all this like weird stuff, as well as like doesn't have anything like, for generics or whatever. So it like invites all this like complex stuff to be handled by the libraries by using the reflect package. And I think it contributes to the problem, and we're all experiencing by like doing all this like lm.lms and don't necessarily understand why, but it's just, where the entire language is somewhat contributing to the problem.
That's another good point you made, is that if you're working with reflect, you're almost always accepting the empty interface. Like that's almost always what your argument is. And that's usually a bad sign for code when that's what you're accepting.
Yeah, but like you say, in some cases it's unavoidable. Yeah. And one of the things that a lot of us use every day is the JSON marshalling and unmarshalling. And that with that thing, you pass in, you can pass in any type, because of course it can unmarshal into a struct type that you've written, or a map, actually a map string interface. It can do that, no problem. And it actually, the reflect package can instantiate things too, can't it? It can, if you pass in a map, it will create the map for you, right? And things like that. So it does get quite strange. And I remember in the early days, I was writing a mocking thing for Testify. And I really wanted at runtime to create the mocked struct from an interface or from another struct. And at the time you couldn't do it. But since then I've actually seen, I don't know if it's possible, but I've seen functions and methods that seem like you can actually now instantiate structs and things. I'd have to check, but that is quite powerful. And if you feel like, if you think about it, we don't have generics, it is quite tempting to have a look there and see if you could do the work, the hard work, and get it done, and then have this extremely intelligent, dynamic kind of functionality, which would be very interesting. And in test code, maybe you're okay with that not be, it's not going to be in a tight loop. You don't want test code to ever be slow, but it's not going to be in a low latency situation running tests all the time. Of course, we still want test code to be very fast.
Yeah, it's like Jaana said about how the typing system is limited, and then you mentioned like the JSON encoding, and I'm sitting here thinking like even cases where you have to pass in a pointer, like, if you can't just pass in the struct, you have to pass in a pointer to the struct to, get the values back. And like even having a typing system that sort of allowed you to restrict that would have helped. But because of the way things are set up, it can't do that. Instead, you have to rely on maybe an error or something. This is not meant to be like, bash and go or something. It's just, it's a struggle sometimes when you see that, because it's, I'm sure, confusing for some people.
Yeah. Well, what would the JSON package, what would that look like if it didn't use reflect? I mean, you almost certainly would have some kind of callback but you'd still have interfaces because you don't know the value type.
Yeah, it would almost have to be something like encode this, and then like instead of saying pass an interface, it'd almost have to say like it has to be a pointer, or it would almost have to be something along those lines. But even then, that's confusing because maps don't always work that way, if I recall correctly. Like I think you can just pass a map in there, and it doesn't have to be a pointer. But I don't remember. Does it have to be a pointer to one? I haven't passed map into that in so long that I should go check.
What have you been passing in?
Structs.
Oh, yeah.
I decode into structs most of the time.
Well, if you're writing anything where you don't know the data structure, some APIs do that. I mean, it is kind of dangerous territory, but if ever you don't know the actual types, I mean, I wrote a little, it's not finished. It's kind of works, but it's not by any means ready. But it's basically a fake JSON data generator. So you pass in any data. I mean, you can pass in a struct, in fact, and it will generate lots of examples of that struct, and it uses JSON to do it, because actually just marshalling to and from JSON, at least in the API, is a very easy thing to do. And so in that sort of case, yeah, if that was an API hosted on a website, you would want people to be able to pass in any kind of JSON, including an array of objects as well as a single object. And then it could maybe then generate some test example data from that. That was the idea. And that was very meta. So those use cases aren't as common, I suppose. But the JSON API, I think, is great for when it comes to just, as a user of it. Yeah, it would be strange. You'd probably end up, if you didn't have reflect, you would end up with some function where you get given the key as a string and maybe the value as some bytes. And then it's up to you, based on your knowledge of your particular situation, to then kind of unmarshal those bytes. And so it is nice that the standard library does that for us, for sure. And by the way, if it didn't have that, I think that would hurt Go's reputation. I can't, imagine the Hacker News article on this, of how you have to do JSON marshalling,
Yeah, I mean, Go wouldn't be adopted this, widely if that was not a thing.
That's right. Absolutely.
Even with it as is, there's already a couple cases with JSON that are challenging. Like you said, you have structs, but I think Stripe's an example of this, where payment sources can be a card or a bank account. So you have this array of things that can be different, and you kind of need to write your own type to unmarshal it correctly. So you end up having to write some custom stuff for that. And I imagine if you just didn't have the JSON package at all, that it would just be a nightmare of people complaining and saying this is awful. Because even in cases like that where you have to write custom, I still leverage as much of the JSON package as possible. Make a struct with just that one field I want, unmarshal it, figure out what it is, and then pass in the struct for whichever type I care about. And that just saves me the work of doing any of the actual overhead of how do I unmarshal this. Hi everyone, panelist John Calhoun here. As many of you know, when I'm not recording Go Time episodes, I create programming courses. Some of these are paid, and that keeps the lights on at my house, so thank you to anyone who has purchased one of those. But I also offer free courses. One of those free courses is Go for Sizes. It's a series of 20 Go programming exercises, and in each exercise we build something new or improve upon something we built in a previous exercise. Each exercise is designed to teach you something unique about Go, and they're also a lot of fun. So if you want to check it out, you can do that at goforsizes.com/gotime. That's GOPHERCISES.com/gotime. Or you can think of it as Gopher plus exercises mashed together into one word, because that's where it came from. So earlier, Matt, you were talking about struct tags. And one of the things Jaana and I had sort of talked about a little bit before the show started was, in some ways, I kind of feel like struct tags would benefit being its own separate library, would benefit from that. Because then you can kind of separate this. I feel like struct tags are the safest version of reflection out there, or, where you import the reflect package. And then everything else is kind of the, maybe not worse, but it's definitely a little bit scarier. So having that, edge case where you could just pull out struct tags might be useful to actually have as a separate, okay, I'm just looking at struct tags here.
Yeah, I see what you mean. So that you don't have to have all the entire reflect package imported into your code. And I think the reflect package also has unsafe in there. Although I think there's a lot of very normal packages also do have unsafe. But yeah, I see what you mean. So that you would, in order to parse the struct tags, you would import a different, a reflect/struct tags package or something. Quite like that, mate. You should tell someone about that.
I remember in the earlier days of Go, they were saying hey, if you're importing reflect package, that's a no-no. It was almost considered as an unsafe, because you also are dependent on unsafe for a lot of the reasons and so on. But it was one of those import lines that you should never see, or you should be very careful if you have ever seen it, and you should be very controlled about your usage and so on. But all of a sudden everybody starts to import reflect, because it does a lot of like fundamental things like the struct tags. So I think it just kind of also gives a lot of like mental separation to the user if it was a separate package. So you can write linter tools and whatever to catch for import reflect, but like at least like some of the basics or some of the like more easier concerns can be living in different packages. And one of the things that I've seen related to this was people, if they want to rely on the reflect package, they don't necessarily import it all around. They just kind of like go and like encapsulate like all the reflect usage in a different package, and then they provide some utilities from that package. Have you seen anything like this, or have you done anything like that?
No, but that makes sense to me. At least then you've got all of that weirdness in one place. But I don't know if that's a healthy approach, because that's just, that's kind of like kitchen sink or utils sort of.
I've definitely done the have
sort of.
one file, like source file, where like this is where all my reflect stuff got put. But like I've never done anything big enough with Go's reflection that I've had to go that far. Now, I can say that I'm definitely guilty of, in like Ruby, going crazy with some of the metaprogramming stuff, but I kind of feel like when I went to Go, it just didn't feel like writing Go code. It didn't seem like the right approach, so I kind of veered away from it where I could.
Yeah, I saw an example where somebody wanted to be a very good citizen, and they were going to put some data in a map, and if the map was nil, it was panicking, of course. So they were actually using, I think, the JSON unmarshaller. If in the case that the map was nil, it would just marshal it, and they put the string in line, like the two little curly braces to denote an empty object, and they would actually create a map using that technique. Which means as a programmer, you then could pass in a nil map and it would still work. But again, it's a bit too magic, and also just kind of letting it panic, or since it was a library, even sometimes I don't mind catching situations that would panic and then panicking with a better error message, like you have to pass, you have to create the map before you pass it in or something like that. But yeah, I've seen a few cases where it's been used where you don't really need it, but people have tried to kind of go the extra mile for their users. So yeah, those kinds of things are quite interesting. Another form of reflection is with the AST package in Go and some of the actual kind of code reflection, code analysis packages. And they kept getting better as well. They were very difficult to use. And there are a few higher level packages now that makes it a lot easier. We have a project where we actually describe our API in Go interfaces, and we use that sort of AST. There's a packages package, which lets you actually open a package, and then you can walk through interfaces and things like this, and then inspect the fields inside the interface and things. So it does that kind of reflection to then, it represents that data in its own structure, and then uses that to generate code from a template. So it's nice because we have all of our APIs are described as Go interfaces, which since we're Go developers, that's very easy for us to understand and reason about. And also it's a real Go package, so it's type safe too. You can't use invalid types, so it's a great way to describe an API, it's going to work. And then we can generate the client from that. We generate the server code, the HTTP stuff, the stubs, all that stuff, anything boilerplate can get generated. And we even generate another interface, which is actually slightly different from the original one because it takes a context and returns an error. And we omitted that from the definitions. And so we then we can write our definition interface, we run the code gen, and then we implement the interface, and that's it. We've then got a new service that's then exposed in our project.
When are you open source on this?
I think you already did.
It's open source, yeah. It's called
Really?
It's called Oto, yes.
Very nice.
It's good for it's basically JSON. It's a JSON API at the moment, but actually, since it's just code gen and they're just templates, you could easily write a binary protocol for it, or any other type actually. Yeah, so it's nice. Somebody's written a server Rust template for it too. So that's quite weird, but kind of awesome also. We'll put it in the show notes. It's github.com/paste.dev/auto, but I'll put it in the show notes for anyone that's interested. And we're using it in production, and it just works great. I mean, our use case is somewhat simple, but it's a really nice kind of, and it's reflection really, because we have to programmatically inspect those interfaces and then do some work with them, you know.
So Matt, I'm assuming that you're generating code with Auto.
Yes, that's basically what it is. It takes Go interfaces, mixes them with with a template, and generates new code.
I was going to say, I do think we talk about how reflection is bad, or you should try to avoid it because it's confusing, it's hard to reason about, and it's just hard to maintain. But I think sometimes that's hard because we don't tell people alternative approaches. And I do think code generation is one of the big ones out there that can be very useful. Like you said, you're kind of doing that like reflection thing where you're actually analyzing the code, and then you generate code from it, and you end up with something that's much, much easier to manage about. And I've even seen some ORMs that go with that approach, where I think SQL Boiler was one of them, where basically they would scan your database, your SQL database, and then they would generate Go structs from that.
Right.
So like rather than using reflection, they're like, okay, we're just going to spit out things that match your database perfectly, and you can just use these. And it's a very different approach, but I think having reflection being kind of limited forces people to look at these other approaches and decide, is this better? Is this easier to maintain?
Yeah. I mean, there's also the Go generate feature, the command, and you can put a comment in, special comment, which again is a little bit magic, but it's like 2/ go : generate, and then a command. And then if you type Go generate in your project, it will run those commands, and they're useful for exactly that kind of thing, where you're gonna do a sort of pre-build step where you generate the code. And that is a nice approach because you get the type safety, you get the compiler helping you, not maybe initially, but once it's generated, that code then is part of your project usually, and it's going to be built. And if it's wrong, you'll find out soon enough.
That's exactly what I was about to tell. I think the difference between the AST package and the reflect package is like the AST package is a static thing, right? Like it's not doing things in the runtime. So you generate, you still have the similar level of maintainability as well as type safety. You just generate some stuff for the compiler. So if you can hand off some of the problems to code generations, that's definitely something to do.
Yeah, that's a great point.
We talked about generics earlier, and I would actually love to see an implementation of generics that essentially just runs a Go generate at the start. Like you write your code as if generics are there, like using a proposal, and then it essentially just compiles it using, some step beforehand into Go code and generates whatever it needs to generate and then goes from there. Because I think it would be possible. It would just take some tricky work.
I wrote exactly that project with a friend of mine, and it's called Jenny, and it's used. People use it. It uses a special type, which is just an interface type in a different package. And then I think it's the AST stuff again. It goes and finds those instances and looks for where you list it in the command. You run a command and you list the types you want to support. And then it is just a kind of copy and paste. And it replaces that type wherever it's mentioned. It's not perfect because you can't do type assertions on it. It stops making sense because, it just gets quite weird. But for simple cases, it works. I think that's what you're talking about.
I've used something like that. I guess what I'm thinking is it would almost be nice to take that idea and expand it farther to be like the current generics proposal, to make it so you can write code exactly like that. And because one of the issues with generics is the fact that it ends up making some of the different steps with compilation and everything else more complicated. So rather than baking that into the compiler, if you could just have a pre-compile step where, it seems kind of like it's already built into the language, but it really isn't. It's like translating it at that point.
Right.
Now, it might end up being so annoying to do that it doesn't make sense.
To me, generics has always been like, hey, there's this template and you generate things, and the compiler is handling all of that stuff because, the generated code is too complicated to take a look. And, that's why the language needs to provide some synthetic sugar to be able to, engage with those types and so on. So I wonder, I think if it expose what is generated, that would be super scary to the user. You will have all these like, dash dash types and like all these like, different cases and whatever. So I think that like it's not going to look really good for a large number of cases. And that might kind of like discourage people to take a look at generics to begin with. That's why I'm like waiting for the, the actual generics proposal and implementation, because, I want to see that synthetic sugar, how it's going to look, even though the hard work is not visible to me, at least like, I'm not really interested in the, what is generated under hood, because I know that it's going to be complicated for a lot of times. And I think one of the reasons that like these generators or stuff, the generic, the temporary generic proposals didn't really catch up. It's because you need to have like some sort of like an officially blessed generics solution, right? Like as a library, I can't really like randomly pick one tool versus the other. There's not a lot of like experimentation actually. Like you can't really expose what's underneath. I just want something that works for everyone, so we can agree on it. All the library systems space kind of like switches to it. I don't really care what's like, generated under hood, and they can always optimize it, whatever. Like there's like so much like work have been done in this field. So we're not like trying to do this for the first time. So I assume that like we should find a solution to generics. It should be in the, the official language. And I don't think that like we need that much of experimentation, but it will be hard for people because, it's going to definitely complicate the language.
Yeah, but a lot of JavaScript libraries they have like this approach where they have a shim essentially, or they do like, I think the TypeScript originally was, or Dart actually, Google's Dart was originally just transpiling to JavaScript, and it did look ugly. But Jaana, you just have to not look at it, mate. Just call the file, don't look at this .go, something.
I think you just have to train people that like, it's almost like you build a compiler on top of a compiler, and like that's the one that gives you errors and you interact with, and then like the compiled, whatever it compiles into, then eventually compiles into, you kind of have to hide that away somewhere in like a bundle folder or something.
Yeah, but you think about the IDEs and everything breaks when suddenly you've got syntax that's not valid. None of the tools would work.
It'd be much harder now, but with the changes they're doing to how the different IDEs use the language server, hopefully that sort of thing, experimentation. Yeah, so like basically the fact that they're all using kind of like a common, I forget what it's called, but basically like the language server, like there's a common spec for all the different languages to implement. So hopefully that type of work will lead to more potential experimentation on top of existing languages. So that could be interesting to see.
Do you want to just give a quick overview for anyone that doesn't know what is a language server? I think it's LSP, isn't it? Language Server Protocol.
That sounds right. So the general idea is that rather than every IDE or editor out there implementing their own like implementation of how Go's autocomplete should work and how JavaScript's autocomplete should work, I think VS Code was the first one to standardize it, but I think others are using it now.
Yeah, I think it came from Microsoft. I'm not sure.
Yeah, yes. It did. It came from Microsoft's Visual Studio Code.
So the idea is that they come up with sort of like, in Go terms, an interface, or like this is what an LSP should spit out for a language. Like if you're typing, whatever, and it like basically it should have some methods there that you implement, and it can give autocomplete suggestions depending on where the user is. And the idea was that you could then implement that for any language, and then any IDE or editor could use it to implement autocomplete inside of the editor.
Yeah, which is amazing. And honestly, I can't actually believe that works because of how different all the languages are. How on earth have we found a protocol where you can just describe any of it? I find that to be quite amazing, actually. And no doubt it's non-trivial as a protocol.
It's probably one of those, there's probably like 1% of edge cases where it's not that great with. But for most developers, that just doesn't matter enough to outweigh the benefits of having the LSP.
Yeah.
But then there's still the problem, not problem necessarily, but different editors use their own approach to this. Like I think Goland is one of the ones that doesn't use language servers. They use something completely in-house. And in some ways that's beneficial because when Go Please first came out, it was pretty brittle. Mm-hmm. But, and theirs I think was better at the time with Go modules. But now I don't know if that's necessarily true.
I've heard very good things.
That's usually what JetBrains do, right? They build everything in-house.
Yeah.
That's their like niche. Yeah.
Yeah. My only thing is a few times that I've had to touch Java, I've had that kind of Eclipse IDE, and it really, it's an aesthetic thing, actually. I use Visual Studio Code because it kind of looks so much nicer, and you spend so much time in there. I feel like it does matter. I feel like you want it to be a beautiful experience. But I've heard some amazing things about how that Golang editor, the features it has, the things it can do. I haven't yet played with it, but I would be interested if anyone would like to tweet at me and tell me about their experience. I'll probably read it.
Probably.
The Changelog is deep discussions in and around the world of software, and it's been going for over a decade. We interview hackers like Chris Anderson from 3D Robotics.
At the time, drones were like Predators and Global Hawks and military industrial, and they were classified and super, $10 billion things. And we had just built a drone with Lego pieces around the dining room table programmed by a 9-year-old. And it's like, okay, that should not be possible. When a 9-year-old can do something that is classified, that literally export control as munition with Lego, with toy pieces, something important in this world has changed.
Leaders like Devin Zugel from GitHub.
In the 10 to 15 year range or 20 year range, what I would really like is for, if you have 3 12-year-olds hanging out and one of them's like, I want to be a firefighter. Another one's like, I want to be a lawyer. I want one of them to say, I want to be an open source developer.
And innovators like Amel Hussein.
I've yet to kind of see applications at scale that don't use multiple languages, that don't have just arcane stories behind why this weirdo thing exists, all right, when you open this file, you're going to have to turn around 3 times and tap your nose once. It's just the most hilarious stories, But applications are living, breathing. They have craft. That's normal. So I want to normalize weirdness because that's just how applications evolve over time.
Welcome to the Changelog. Please listen to an episode from our catalog that interests you and subscribe today. We'd love to have you with us.
Guess what time it is? Guess.
I think we know it's probably unpopular opinion time.
It's unpopular opinion time.
Unpopular opinion.
I actually think you should probably leave.
Unpopular opinion.
So does anyone have an unpopular opinion then? I mean, some of these things we've already said probably are a little bit unpopular, but have you got anything in particular?
I have one.
Go ahead, Jaana. I'm going to let her take the stage.
We need generics. I think this is not a very unpopular opinion, but I've been saying this since the beginning of the language, and everybody has been hating me. But I think we need generics.
See, I agree entirely, but that's because I've done enough. I think one example is for Go to do well in an educational space, like for people to pick it up in college, they're going to be dealing with data structures. And it's really hard to do data structures without generics. And I think that's one of the reasons why Java is taught so much in schools, is because it does well with that.
Yeah. What do you think about the recent generics proposals?
The ones I've seen, or the most recent one I've seen, I liked. I haven't gone too deep into it, but it seems fine to me. I'm not too particular. My needs are fairly limited.
I think they're making great progress on the design of it. And of course, you hear a lot that the real concern is implementing it, what that does to the type system in Go, and how easy that's then going to be to maintain, and things like this, which is great to hear that there are people on the Go team and other contributors that really prioritize that, because it is kind of vital, really. I mean, it would hate to get to the point where we can't add any more features to Go because it's just too complicated now. So I'm with you on that one, Jaana, actually.
Actually, I'm super burned out from this topic that I stopped following the proposals a year ago.
Why were you just getting really emotional about it?
It's not being emotional, but there are at least 50 concerns I had about every proposal.
Oh, only 50.
And there are no easy answers. Yeah, I mean, it's high level ones.
You're making other people emotional.
Exactly. And I think I was not like really contributing to the discussion, and lots of like the points that that was in my mind and I was like feeling anxious about is like you can't truly anticipate what the reality will be like, because it really depends on the people who are going to take the generics and like use it, and we'll see it over time, like how it's actually going to impact the entire library space. So I was like feeling like, hey, I'm not really contributing to this discussion, and I'm excited that it's happening, and the people, I am almost certain that they care a lot. Like they care more than me, so what's the point of trying to contribute to that?
Like, one of the things this reminds me of is the type alias and how much pushback that got, and like how it was going to ruin the language. And ever since it's come out, I don't feel like I've seen it occasionally you'll see it. And I've done some weird things with it, just kind of messing around to see what was possible. But I don't feel like I've run into libraries that have abused it or anything, which is kind of, it's funny because you just saw all that pushback, and then I get their concerns. I'm not trying to say people shouldn't express their concerns. But it's just funny how like that didn't actually come to fruition at all.
Yeah, but it is in there.
I was just about to give that as an example, because like that was like the moment that I actually started to burn out, like started to feel burnout from the project, and I wanted to go and like do something else. And everything like kind of was becoming this like infinite loop of discussions about what the possibilities and so on. So with generics, I didn't want to, contribute to that because there's already too many voices, and like, it's hard job to figure out, because, you can't predict the future also. I also trust Go developers because a lot of people care about like simplicity. So they never take a feature and abuse it. Like I think Go users are pretty informed about the core subset of the language they want to use, and the language is not huge, but I also trust the larger ecosystem, so I'm not that concerned anymore.
Yeah, I mean, you can always not use it, and to be honest, I didn't quite realized very late that type aliases got into the language. I remember the proposal and the big debate, but another one was the try proposal, that one with the errors. Kind of, for me, I was allergic to that because, it felt too magic. And yeah, I feel like that didn't fit in with kind of the philosophy of Go. We have to watch out, I think, that we don't just like the Go as it is, and we're too rigid not to allow any evolution. But I do think you're right, Jaana. We kind of are aware, aren't we, of the simplicity and things not being too magic and things, that we are, as a community, quite aware of that. And yeah, I suppose you can always just not use it if you don't like it.
I think this is probably why Reflect is such a weird topic, because people come from other languages where it's completely normal to use it. Like, I think I said it before we started recording, but I don't think Ruby would be popular if Reflect and metaprogramming wasn't such a big thing in that language. Like, Rails and all the crazy things you can do with it are all a byproduct of being able to do metaprogramming. And in many ways, it makes that language more productive. But none of that would make any sense in Go whatsoever. So like when people come from a language like that to Go and they're like, well, why does this Reflect library so hard to use? And why does everybody tell me not to use it? It's a hard mental shift. And I think it's because, it's a different sort of approach to solving problems and a different set of priorities.
Yeah, I think that's right. I've sometimes just, instead of maintaining some, like there's a bit of code that's got reflection in it, instead of maintaining it, I'll rewrite it, because in a way that, that process of doing it is how I figure out what's going on. That's the thing. For me, it is actually hard to maintain, where I sort of give up and instead will just prefer to rewrite it, which I tend to do that if I can anyway, frankly, because I always find rewriting is a way to get a better version of what you have. You learn so much doing it that the second time you write it, it is always a lot better. But yeah, I don't know. It is an interesting one. Well, I think that's all the time we have today. Next week, we've got a very interesting show. We're going to invite on somebody who just got their first job doing Go, and we're also going to invite on somebody who's learning Go and programming in Go who's still at high school. So looking at the very beginnings of people getting into this crazy world that we call just programming and that. So, John, thank you very much. Jaana, always a pleasure. We'll see you next time.
Thanks to listener Rod for requesting this episode. Did you know we take requests? Head to changelog.com/request, pick Go Time in the drop-down, and let us know what you would like to hear about on the podcast. We also have a master feed. It's everything we produce in one easy feed, plus some exclusive backstage content that only hits the master feed. Subscribe at changelog.com/master or search for Changelog Master Feed in your favorite podcast app. You'll find us. Thanks to Matt Ryer, John Calhoun, and Jaana Dogan for an awesome conversation. To Breakmaster Cylinder for producing all of our music. To our sponsors for supporting our work. Fastly, Linode, and Rollbar are longtime partners at GoTime. And thanks to you for listening and sharing GoTime with other curious devs like yourself. That's all for now. We'll talk to you again next week.
That's
Someone's
it.
got to play guitar.
I got to do air guitar, yeah.
You got
No
like
one knows
guitars
that.
in the background, but you're like, nope.
Yeah.
Yeah, I'm not gonna play them though on my other thing. Do you know what I mean? Jaana, you agreed once that I do look like a magician. Do you remember?
Yeah, you look like a magician.
Yeah. You know how hard it is? You take it for granted, but I had to like come out to my parents. I'm like, Mum, Dad, sit down, pick a card.
But you know, it's like this like facial hair, like
Yeah.
this style is very magician.
It does look like a magician. It's ridiculous. I should change it, but
I can just imagine it. You come out to your parents as a magician. They're like, we got to get him a computer or something. Get him into programming.
yeah, get him to be a Go programmer because there's no magic there. I don't know why your family would be against magic, but maybe there's some backstory.
Maybe your parents are like, he's got to move out. That doesn't pay very well. I actually have no idea how much magic pays, but I assume it'd be hard to get into.
Yeah, I think it's difficult. Yeah, I can't think of a joke. It's a shame because there must be loads of jokes just waiting there to be plucked out of thin air. That'll do. That's close enough. I like the awkward silence after a joke. That's my favourite bit.